Welcome back to our unit on autonomic drugs. So far, we've covered the drugs that modify the effects of the parasympathetic nervous system, and it's time we moved on to the sympathetic nervous system. There's nothing that represents the nervous and exciting energy of the sympathetic nervous system quite like those awkward preteen years spent at summer camp. Remember summer camp? The camaraderie, the pranks, the classic rivalry against the wealthier and athletically superior camp across the lake? Well, the memories are all about to flood back, I promise. The sympathetic nervous system is an important regulator of virtually all organ systems, and is particularly key in the regulation of blood pressure. The ultimate effects of the sympathetic stimulation are mediated by the release of norepinephrine from nerve terminals, which then activate adrenergic receptors on postsynaptic sites. Also, in response to a variety of stimuli, such as stress, the adrenal medulla releases epinephrine, which is transported in the blood to target tissues. So in other words, epinephrine acts as a hormone, whereas norepinephrine acts as a neurotransmitter. Drugs that mimic the actions of epinephrine or norepinephrine are called sympathomimetic drugs. So let's sketch in our recurring symbol for drugs that mimic the effects of the autonomic nervous system, a mime. But this time, it'll be reenacting the classic fight-or-flight scenario, getting chased by a bear. So all of the drugs in this sketch will ramp up the sympathetic nervous system, activating that flight-or-fight response. So all of the sympathomimetics can be grouped by the spectrum of receptors that they activate. So at this sympathetic summer camp, we're going to depict these receptors in front of our 4 cabins: alpha 1, alpha 2, beta 1, and beta 2. And in front of these cabins, we're going to highlight the distinct mode of action and the end organ effects of each of these adrenoreceptor subtypes. Just like muscarinic receptors, adrenergic receptors are coupled to G proteins that function as transducers, and each G protein class leads to a specific set of intracellular messages. See the sail on this makeshift raft, and as in an awkward first kiss at summer camp, and it looks like these two star-crossed lovers from the rival alpha and beta camps have carried out a carefully planned getaway. KISS, spelled Q-I-S-S, represents the G protein class coupled with each adrenergic receptor subtype in order. Alpha 1, alpha 2, beta 1, and beta 2 are coupled to GQ, GI, GS, and GS, respectively. Right, let's discuss the end organ effects of each adrenoreceptor subtype, starting with the alpha receptors. Over on the left side of the river is the Alpha Scout encampment. These khaki overachievers have noticed that one of their scout brothers has gone missing, and the search is on. At the Alpha 1 cabin, first take notice that there is one lit candle. In future sketches, when we want to convey Alpha 1 activity, we'll sketch in a single lit candle with an alpha-shaped wick, like this one. And just like M1 and M3 receptors, Alpha 1 receptors are coupled to GQ, which means that they activate the IP3-DAG pathway, or as we at Sketchy call it, the 3 DAGs pathway, which will be represented by these 3 bloodhounds, hot on the trail of the missing scout. Because this pathway leads to increased intracellular calcium, one of the dogs is holding a calcium bone. Remember that all this calcium release activates smooth muscle cells, such as those in vasculature and sphincters. In fact, alpha 1 receptors are widely expressed in vascular beds, and their activation leads to arterial and venous vasoconstriction. See the red leashes pulled taut as the bloodhounds stagger forward? This represents the increase in peripheral arterial resistance due to alpha 1 activation. Specifically, we've designed the leashes to resemble constricted small arteries or arterioles and precapillary sphincters, which leads to a dose-dependent elevation in blood pressure. These blood pressure effects are depicted here by this map elevated by this scout, representing an increase in MAP, or mean arterial pressure. Whenever we want to convey that a drug causes a rise in blood pressure, we'll include one of these elevated maps. Alright, recall that alpha 1 receptor activation also leads to venous vasoconstriction. So let's sketch in another alpha scout, manning yet another pack of bloodhounds, and this time with tight blue leashes, resembling constricted veins. This leads to decreased venous capacitance and increases venous return, which is useful when combating hypovolemic or distributive shock, and thus altogether minimizing any significant changes in cardiac output that may be caused by reflex bradycardia. As the next scout in the search party gazes through his binoculars, notice his dilated pupils. Remember, we're talking increased calcium here, so smooth muscle is getting activated, and specifically the pupillary dilator muscle, which contains alpha-1 receptors and causes mydriasis. Also, notice as he pulls a little overzealously on the drawstrings of his pants, remember that alpha-1 activation results in the constriction of smooth muscle and sphincters in the genitourinary tract, including the prostate and urethra. And this contributes to urinary retention. See that tightly closed bladder canteen? That's not emptying anytime soon. Let's move on to the Alpha-2 cabin, indicated by the 2 lit candles with alpha wicks. These beige backstabbers could care less about their fellow scouts' disappearance. In fact, they've left them with a subtle yet impactful message: crossed out sympathy. Alpha-2 agonists are sympatholytics because when given systemically, they act on central alpha-2 receptors, decreasing sympathetic tone and reducing blood pressure. Alpha-2 receptors are coupled to the inhibitory regulatory protein GI, and GI causes a decrease in intracellular cyclic AMP levels, and this is represented by the deconstructed campsite as these scouts pack up and head home. These inhibitory alpha-2 receptors can also modulate autonomic activity at adrenergic and cholinergic nerve terminals. These are located at presynaptic sites, thus inhibiting neurotransmitter release. This presynaptic inhibition is highlighted by our scout reeling in this presynaptic wire from the electric hot plate outside. By reeling in the power source, he's depicting alpha-2's role in local negative feedback. Sympathomimetic drugs can also exert numerous effects on metabolism. For example, alpha-2 cells are expressed on pancreatic islet cells, and their activation leads to effects on insulin release. Can you guess what effects it has on insulin release? Well, alpha-2 is inhibitory, so it decreases insulin release. See this mat under the deconstructed tent that used to welcome visitors inside? We'll use this welcome inside mat as our recurring symbol for insulin, because the hormone is responsible for getting glucose inside cells. And as you can see, this welcome mat, now rolled up, depicts decreased insulin activity. Activation of alpha-2 receptors on fat cells leads to decreased lipolysis as well, and inhibits release of fatty acids. See this roasting pig dripping with fat? Well, no time for that now. It's time to move camp, so the fire is doused and lipolysis halted. Alright, one last thing to mention about Alpha-2. The scout dousing the fire is using his hat, which looks disturbingly similar to a large eyeball. Well, Alpha-2 receptors are found on the ciliary body in the eye. Some glaucoma medications work by activating these receptors, thereby decreasing aqueous humor production, as depicted by the water draining from the glaucoma cap. At this point, I'll quickly mention a specific alpha-2 agonist used in chronic open-angle glaucoma, brimonidine, represented by the water pouring over the brim of the hat. Brim for brimonidine. Alright, let's move on to the other side of the river, to the beta camp. Remember Romeo and Juliet down there? It's a tale as old as time. The nerdy yet charming scout woos the most attractive girl at the rival camp, a forbidden love. This runaway is one of the residents from the band camp across the river. And see this sign? Remember, we've covered the Q and I of KISS, and now it's time to discuss the GS-coupled beta-adrenergic receptors. The beta symbol has been associated with the word camp to emphasize that activation of GS-coupled beta receptors results in increased intracellular cyclic AMP levels. And that's also why we've erected some camp tents on this side of the river. At the Beta 1 cabin, a counselor is sounding the bugle because it's time to wake up the camp. In future sketches, we're going to bring this beta 1 bugle back whenever we want to indicate beta 1 activity, usually in relation to effects on the heart. As a matter of fact, her shirt even reads, "I heart Bandcamp," because beta 1 adrenergic receptors can be found on cardiac myocytes, including the pacemaker cells of the SA and AV nodes. When activated, increased cyclic AMP leads to the influx of calcium, which, in turn, increases contractility and accelerates the heart. Think of the bugle as waking up the heart. And notice how she's holding this clock up in the air? It's our symbol for elevated heart rate, because of increased activity at the SA node. Also notice her buff arm, too? Yeah, I'm a bit jealous as well, and that's why I wear long sleeves. But a strong, flexing arm will be our recurring symbol for increased contractility, due to the activation of cardiac myocytes. In the end, all this beta 1 stuff leads to increased cardiac output, as depicted here by this heart hydrant, pumping water into the river. Finally, beta 1 receptors are also expressed on juxtaglomerular cells. Their activation increases renin release, contributing to the preservation of volume status and blood pressure. It looks like one of the campers here has donned the old yellow rain jacket because of all this heart hydrant hijinks. So whenever it's raining and you see this open yellow rain umbrella, think increased renin. Alright, we made it to the last cabin, the GS-coupled beta 2 receptor. This is an interesting one because even though we're still talking about increasing cyclic AMP, this time it leads to activation of protein kinase A, which causes relaxation of smooth muscle. See this big dilated tuba? In future sketches, we're going to bring this beta 2 tuba back whenever we want to indicate beta 2 activity. Again, this big dilated tuba should remind you of relaxing smooth muscles. Notice she's taking a huge breath before playing the tuba, which evokes the image of dilated airways. So hopefully this will be a knee-jerk reaction for you. Beta 2 tuba will invoke large dilated airways. The activation of beta 2 receptors also leads to vasodilation in certain vascular beds, including coronary and skeletal muscle arteries. You know, for when you have to run away from the bear. This contributes to a decrease in peripheral resistance, or SVR. And notice that her red sleeves are loose and dilated, just like dilated vasculature. On an exam, you may be shown a blood pressure tracing that distinguishes systolic and diastolic pressure before and after drug administration. Because beta 2 receptors cause that decrease in SVR, you'll see a drop in diastolic pressure. These dangling diamond earrings represent diastolic pressure drop from all that diminished SVR when the drugs have lots of beta 2. This will come into play again later. A couple more beta 2 effects to mention. These receptors are expressed on human fat cells, where they're responsible for activating lipolysis and fatty acid release. Well, here we have another pig, roasting, dripping in fat, but unlike at the Alpha 2 cabin, this time the fire is burning and the lipolysis remains active. Also, someone is pulling marshmallows out of a curiously liver-shaped bag and making s'mores. That glucose leaving the liver represents the increased gluconeogenesis resulting from beta 2 stimulation at the liver. Another girl is bringing a plate of s'mores into the tent with a welcome inside mat. Remember what this represents? That's right, increased insulin, the hormone that brings glucose and s'mores inside of cells. And this occurs because of beta 2 receptor activation at pancreatic islet cells. Next to the girl pulling marshmallows out of a bag are a few banana peels on the ground, and this is because insulin is known to drive potassium into cells. So think of beta 2 receptors generating the same effect. Driving potassium inside cells leads to decreased serum potassium levels, as indicated by our recurring symbol for hypokalemia, spent banana peels. They're banana s'mores, see? Okay, next check out this girl at the side of the cabin. She represents one last beta 2 effect. She's filling water balloons with uncanny resemblance to eyeballs, because activation of beta 2 receptors in the ciliary body of the eye results in increased aqueous humor production. This is how beta antagonists can reduce intraocular pressure in glaucoma, which you'll see in the beta blocker video. Alright, we've been at this for a while, but we're not done yet. There's still a missing scout out there. And just stick with me, and I promise you're going to be able to answer any question about